Then we have our major topic, thermodynamics, concerning the study of thermodynamics properly. So, thermodynamics, we have different labeled thermodynamic processes, thermodynamic properties, zeroth law of thermodynamics, types of system, enthalpy, heat capacity, standard enthalpy of reactions, Hess's law constant, heat summation, and thermodynamics. We have Gibbs free energy. On the right side, the yellow portion is showing Gibbs free energy explanation and their interconversion. So let us move toward thermodynamics, which is a study of heat in dynamic state, means the transfer of heat from one form to another, the study of heat and changes that are occurring in different kinds of bodies with respect to heat and temperature are called thermodynamics. We have the first law, that is the zeroth law of thermodynamics, in which it states that if two thermodynamic states are in thermal equilibrium with the third one, then they are in thermal equilibrium with each other also. Also, thermodynamic properties include intensive properties and extensive properties. So, the first properties that are defined on PTN, properties of the system which only depend on the nature of matter. Intensive properties, like how they depends on nature of matter, like they depend on the state function, which is del U, change in internal energy, change in heat, or change in Gibbs free energy. Let's say properties of the systems which only depend on nature of matter are intensive properties. Alright, and extensive properties are properties of the system which depend on path of the system, and path function is the heat work. Path function is the like heat and work are path functions. So properties of the system which depend on the path of the system like heat and work are the examples of extensive properties. And thermodynamic processes like isothermal processes in which temperature is being or heat is being constant to a provided system. So we have that system as the isothermal system, whose mathematical explanation is del T equals minus del U equals 0. Isochoric or isochoric process in which change in volume is equal to 0 means the system is not being changed in respect to volume. A diabatic process in which del Q equal to 0, in which the pressure is being kept constant and it occurs at certain highest deviation in the graph value of pressure. Then we have the cyclic processes whose del U cycle equal to 0 means the cyclic internal energy is entirely equal to 0. Then the remaining topics includes types of system. So let us move across types of system. We have open system in which matter and energy both can be conserved, can be entered, can be moved outside, can be exceeded, can be excreted, can be indigested to the system. Then we have closed system in which we have matter and energy. Then we have isolated system in which we have matter and energy both cannot be moved outside, or matter and energy can be provided inside to the system. So this type of system is the isolated system, opposite to the open system. And closed system is the one in which energy can be removed or can be indigested, can be moved inside the system, but the matter cannot be. So that is how closed system works. And afterward, what you think I will discuss? We have the universe, how the universe works. As you see that the boundary here, the blue boundary, that one, that boundary, let's say it is universe. So, and the surroundings are colored being or are not colored, are lifted white. So the white is the system, let's say, and the blue is the universe, and the system is the overall cup. So let's generally talking that the cup has a temperature of 25 degrees Celsius. So if it loses its heat outside energy, so that's a closed system kind. So that's how universe, system and surroundings works with each other. As the boundary, there is also a boundary, the boundary of the cup. Between the surrounding and the cup there is a boundary that is called the surface boundary of the cup inside the universe. Alright, So there's general discussion over the topic of universe, surrounding and system. Then afterwards I think we shall move towards the remaining topics related with thermodynamics. So should I move towards enthalpy? That is the easiest and most important topic, enthalpy. Alright, enthalpy. So enthalpy change equal del U plus del, which is mean change in pressure and volume, and del H might be written as del U equal del Ng into RT, which is the gas equation. Yes, I know. And enthalpy of reaction, which is del NRH. For reactants converting to products, will be del ARH equals E summation sign AIH products minus E summation sign BIH reactants. Then enthalpy, standard enthalpy of reaction del H naught, and also standard enthalpy of fusion is also been provided. Standard enthalpy of phase change has also been provided in the same topic. Del H fuse, del H naught fuse, del H naught vaporization, del H sublimation H naught. So standard enthalpy of combustion del H C H naught. Standard enthalpy of bond formation del bond H naught, and standard enthalpy of lattice energy or lattice enthalpy, that is del lattice H naught. So that's how the equation form of different kinds of standard enthalpy of reactions occurs. Then his law of constant heat summation. His law of constant heat summation says that if a reactant A changes to B and B to D, interconversion between different kinds of reactants taking place, like A to D, B to D, D to C, C to D, D to B, B to A, and C to A consecutively, and A to C consecutively. Then we have change of enthalpy for the reaction del RH and del RH1, del RH2, del RH3. So summation of the overall enthalpies will be the overall enthalpy change of His law of constant heat summation. Means the overall heat between the reactants and products reaction are being added, and the overall enthalpy has been written del RH. So this is the constant heat summation law of His. The heat capacity. Heat capacity is the amount of heat required, generally saying the amount of heat required to raise the temperature of a system by 1 degree Celsius. Mono heat capacity 1 degree Celsius, in which mono heat capacity equal NC del T. K equals MC del T. Mayer's formula, we have Cp minus Cv equals R, and Cp divided by Cv equals R2. Not R2 but Cp by Cv equals R. So that's the Mayer formula. And Poisson's ratio is the Cp, pressure constant to volume constant ratio equal to R. So we have sodium gaseous plus chlorine gaseous, in which we have 12 change in bond enthalpy, sodium gaseous plus half chlorine gaseous, and here we have sodium gaseous plus half chlorine gaseous. We have del H sublimation, del half chlorine gas, del H naught sodium chloride solid. We have change in lattice enthalpy for sodium chloride ion. Here in this case, the overall reaction has been recycled in such a way that the overall enthalpy will remain constant at Ehrenhaber cycle, in which we have preparation of sodium chloride. So that's how the overall topic of thermodynamics worked. Now let us move towards our next topics, which are mainly concerned with Gibbs free energy. So Gibbs free energy is the net free energy available to do useful work and is a measure of free energy. Alright, Gibbs free energy is the available to useful work and is a measure of free energy. So standard free energy of reaction will be del H naught del RG naught equals sigma del FG naught products minus sigma del FG naught reactants. Gives and holds the equation, which is a del H naught minus del T del S naught del H naught NFE naught. Then we have Gibbs free energy change in equilibrium, and it's a mathematical explanation you can see. And process is spontaneous. When the process is non-spontaneous and process equilibrium, their condition has been provided. Also expansion and compression equation in terms of Vf and Vi has been provided. Also the sign of del S in different kinds of situation when process are spontaneous, non-spontaneous, equilibrium reached or not. So their values, when they will this be negative positive value, temperature positive. Whenever we provide these values positive, negative, and negative, positive. So in this case, it will be negative spontaneous air temperature, non spontaneous air temperature, non spontaneous air temperature, spontaneous high temperature too. It depends on low and high values of temperature. Whenever we provide in such a case that negative and negative both, so negative low temperature, negative both temperature, like positive and positive case, same case is in here both also. So spontaneous low temperature and spontaneous low temperature also, because both are negative and they are so at all temperature and high temp. Then spontaneity, which is spontaneous movement of molecules across a bridge. Here we discuss about entropy too. So entropy comes from spontaneity. This is the measure of the degree of randomness or disorder of the system spontaneously occurring. The equation here mainly discusses is that the Q reversibility, which is divided by T reversible process, and del S total, which is equal to change in enthalpy of the system plus change in enthalpy of the surroundings. So entropy change during phase transformations, del fusion S equals del fusion HO, which equals del M dot T del vaporization, S equal del vaporization, S equal del vaporization divided by Tm. And then we discuss del sublimation S, where del sublimation is divided by Tm, and del RS not products minus sigma S not reactants. So according to Gibbs free energy, we also have isothermal and reversible processes being in here. Isothermal reversible work, in which we have the equation PV minus P external del V. Thermal process, we have the value constant V1 divided by V2 divided by V1 final divided by initial. Diabatic reaction, we have T2 minus T1. For adiabatic reversible, which is not reversible but irreversible, so we have equation like this. We have P1, you can see in here P1 T1 minus P2 del 2 divided by P1 T1. So we have free expansion afterwards concerning work and internal energy. So heat exchange of energy due to temperature difference, total energy within the system, and difference between the process system and surrounding the work done is known as W. So we have free expansion also. You can see at the free expansion topic, when an ideal gas expands in vacuum, then P external equal to 0, work done is also equal to 0 second. So according to this, we also have from internal energy, we have first law of thermodynamics, law of conservation of energy, total energy in a solar system is constant. Mathematically, we have this value, alright, Q plus del W equal del U. We have sign confusion for, we have some concern about first law of thermodynamics. Constant volume, we have del Q, del U equal Km. Constant pressure, we have del H is equal to Kmp. Heat absorbed by the system, the positive heat absorbed by the system is always negative. Heat absorbed by the system is heat absorbed by the surrounding is always negative. So work done by the system is always negative, and the work done on the system is always positive in this case. Alright, positive on the system, by the system, and by the surrounding, and by the system, positive, negative respectively. We have according to the same processes, we have calorimetry, which is the measure of calories, energies in terms of calorie unit. Alright, so from here internal energy is also related with the from here with the standard enthalpy change, which we discussed earlier in terms of internal energy, which is the mathematical equation for second law of thermodynamics, that one. Alright, you can see here. Then entropy, which we defined earlier and described it very brief. So the mathematical representation, that were all overall about thermodynamics topic. So good luck for now, and see you soon. Goodbye. We discussed just thermodynamics topics, which you can see here. I will give you a detailed overview again. Alright, thermodynamics, zeroth law of thermodynamics gives free energy, gives energy, expansion, compression as thermal systems, spontaneity, free expansion, entropy, second law of thermodynamics, third law of thermodynamics, calorimetry, sign convention, first law, internal energy, work, heat, state functions, path function, etc. Von Hebel cycle, heat capacity, also heat law. This is law of constant heat summation, standard enthalpy of reactions, enthalpy, and types of system, the universe, how is it surrounded by us, and properties, etc. So these were all the main concern of thermodynamics law. So wish you best of luck, and bye. Good luck, have a nice time.